Hello, everybody. So good to see 10 people online. Welcome. Most of you have your mics off. That's okay with me. This is an experiment. Like last week, we had an experiment. We did a session with Microsoft Teams. That worked well, but we had a delay between what you saw and what we did, which makes interactive sessions quite complicated. For today, we've chosen Zoom because people told me Zoom is a good environment, and well, let's give it a try. What I would like to do today is focus on one particular part of X Sharp, and that is the runtime state in X Sharp. Historically, D-base, X-base environments had a global state, which in a modern app you would never do, but that's the way it worked. So you had global state for settings like the deleted, unique, softseek, etc. We've implemented that in X Sharp as well, but we also wanted to be ready for multi-threading. So what I'm going to show you today is a bit how we've done it, and what multi-threading has to do with it, and how you can use it to your advantage, and how you can find potential problems. I'm going to share my screen now. Okay, so what you see here is a blank screen of Visual Studio 2019. This is, as you can see on the top hand, it's a preview, so it's the latest one. We try to test that one, so we see the potential problems with Visual Studio before you guys do. Unfortunately, that doesn't always work. So this week, for example, someone discovered that something in the debugger wasn't working right, but we'll do our best. Okay, let's just start with a new project. And then we see during the running of this project what the runtime state is, and how you can see it in Visual Studio in the debugger, and how you can use it to your advantage. If you have questions, use the chat window. And Daniel says he can't hear me. Can other people hear me?
This is Matt. I can hear you just fine.
Okay, thank you. So it must be something in Daniel's settings. Okay, good. I'll start with a VO-MDI app. The app itself is not really important. What I want to show you is how you can see in Visual Studio what the state of your runtime is. So how all the settings are. So this creates a standard app. It's not the best app in the world. It starts with a app class. For those people who have no visual object background, this is like the standard visual objects app. And I want to set a breakpoint in the standard shell window. And before I do, I have to check. Yes, I've enabled just my code. Okay, I'm going to build this one. It doesn't build really fast because I'm on the development machine, and I'm running a debug version of the compiler, which gives me a bit more information if there's a crash, which again we hope to see at our machines, not at your machine. Okay, it's compiled. Let's run. I'm going to step into this class, and as you can see in this class, it calls a function set deleted. Now, in other X-based languages, there's a function called set, where you can specify a string deleted or a set ID, which sets a global flag. Now, you will see this a lot in applications. And the biggest question so far I've received from people is, where in Visual Studio is a window where you can see this? Now, Chris has his own IDE, and he has a window with the settings. Unfortunately, we do not have it yet in Visual Studio. But I'll give you an example of how you can see this information. And this is something you may want to write down. You type here runtime state.getInstance. And if you do that, you'll see that you get the thread state for 1. And if you open it, you see a list of settings. These settings are all global states that you will have in your app. Some of them you may be aware of, some of them you may not be aware of, stuff like set exact, set fixed, set decimals, set exclusive, set soft seek, etc. And this particular function call sets deleted flag, and this should be visible somewhere here. Let me see. I can find set deleted. Yeah, there it is. So if I step through this code, it has updated. Now the thread state was a function or a method call, so it doesn't actually automatically refresh. Otherwise, Visual Studio has no idea about the side effects, would slow down too much. But you can see that this has indeed changed. So the runtime state is stored in something which is a runtime state object. And over here you can see the static members. And if you are interested in a specific state that you want to follow and you do not want to refresh it, you can go and, for example, take this one and then say add watch. And as you can see now, Visual Studio has a watch for xsharp.runtimestate.deleted. And this way you can always see what the current value is. And this may be a way to retrieve other information as well. So let's look into this. If you want to see, keep track of what the setting is for digits or for epoch or for you name it, you can see it. Or if you want to see what the latest low-level file access error is, there it is. So we have stored all of this in a class. Now, in a minute, I'll show you how we've done it and how you can use it further on. But this is to begin with a simple way to retrieve the runtime state. Now, let's run this app. And now I'm going to open the file. And I'm going to the file open function here. There it is. This presents an open dialog. I'm going to open the customer file. As you can see, when I step in here, I have a file named customer, and this is now going into a constructor of a class. Skip over this. And as you can see, this creates an instance of a server class. And the server class is going to open this file using an RDD. So it's going to open the cursor, FoxPro people would say. Now, wouldn't it be nice if you could see which files are open? And that's also stored in the runtime state. Not in the get instance, but another one that you may want to remember, as long as we don't have the window in Visual Studio, is runtime state work areas. Okay, this is a capital A, and unfortunately, why doesn't someone tell me that I'm making a typo here? Come on. It was lower A. There it is. Okay, only 3 efforts. Runtime state work areas is a property that gives you an overview of all the work areas that are open. At the moment, you can see that the current work area is null, which is basically nothing. But when I step over this particular line, you can actually see that the current work area is now a dbf NTX work area. And what you see behind, in parentheses behind it, is that its alias of the cursor or the work area is customer. So, and this is indeed the customer table. Now, if I open another one, you can see that the current work area is now orders. And the work area number is 1495. And I take another one. Let's do the details. And now we have 3 work areas open. Let's break and refresh this. Why doesn't it? Because it's running. Okay. Do it again. Right now you see that the third one is also open. What if you want to see which all of the work areas that are open? It's again in this particular work area structure you can see a couple of things. For example, you can see all the aliases, all the names of the cursors. So we have 3 now: customer, order, and detail. And these are the area numbers in which they are opened. In case you were wondering why these area numbers are so high, the DB server class selects -1 and says, give me the last one in the list. I have no idea why it was designed that way. This is how it was designed in Visual Objects, and we've implemented it. We made a change that we changed the maximum number of open work areas from 1024 to 4096. I think it's way too much, but it works. So this is a list of all the names with the numbers. And in the RDDs list, you can see, of course, lots of unused on the bottom. Come on. You can actually see the 3 RDDs. Now, I'm not going to go into very much details about these RDDs, but if you have a quick look, you can actually see that each RDD, or each area basically, is implemented by an RDD, in this case NTX, and you can see some of the properties of that area. So you can actually see the begin of file flag, the end of file flag, the number of fields, a number of records, etc. In another session in the future, I will go into a little bit more details about work areas, but this gives you an idea about where this information is stored. Now, let's have a quick look at the source code. Do we see this as well? Yeah. Okay. This in my out of Visual Studio, I have opened the X Runtime source that you can find on the web. For those of you who don't know where to find it, it's in GitHub on X public, and we have several feature branches there. And if you want to see the current state of development for the runtime, go to the runtime feature branch, and there you see a runtime folder with the core, RT, various components that we have. This particular version of Visual Studio is now in the feature runtime, as you can see on the bottom right, and it has, at this moment, I have the runtime state class opened in my editor. Now, what you see here is that this class is a bit strange. And why is it strange? Because we try to make it in such a way that each thread will have its own runtime state. Now, what we're doing inside the state is that we're keeping track of all kinds of settings in a dictionary. And this particular dictionary links a set ID. So let's say something like set deleted, set exact, etc. with a value. At startup, we initialize this particular set of values, and then at the class itself, we have, let's look at one. Let's look deleted example. We have a property called deleted, which is static. And what it does, it calls get value with a logic. So this is the syntax for a generic method, basically. So this determines that get value will return a logic value. And if you go to get value, I think this will work. No, it doesn't. Not today. Where are you? Get value is a static method which does this. It says get the current state. This is the runtime state for the current thread, and get its value. So this makes sure that we can access the class like a static class. We can say runtime state dot deleted, but internally it's going to map and get the current state, so the state for the current thread, and get its value. And by doing that, we can access it like it's, we don't have to worry about getting the right state, basically. So we call a static method on, or a static property on the class, and it redirects it to the right state for the right thread. Work areas is the other one that we saw, and this is a class that's actually like a kind of collection of RDDs, and it keeps track of which RDDs have an alias, etc. If you are interested, have a look at the source. If you have questions or suggestions, please let us know. What I wanted to do next is show you a bit about this particular multi-threading thing, because I think that was, we wanted to add that, but that made it actually a bit complicated. I'm going to reopen a solution, and I must admit that the code that you're seeing is not my code. This code was written by a colleague from Wolfgang, by Andreas, and he wrote it to test the multi-user, multi-threading capabilities of the CDX driver. Now what this code does, it creates a file. As you can see, it has a file with just two fields, two numbers, and then it has an index on field 1, and then it's going to create two threads, a thread with the name doWork1 and a thread with the name doWork2, and they both will call a method doWork, and inside this method it is going to create records, and if everything runs fine, then at the end all records should be in the DBF. So as you can see over here, it loops from 1 to 100 and then waits for a random time and starts to append and field puts, and it field puts the NID, which is the loop, and in the second field it puts in the nparam, which is the ID of the thread. So in the end we should see records with the thread number 1 and records with the thread number 2. Now let's just run it, and then I'll go into explain it a bit more in detail. Now this is of course not very spectacular, but you see there are random waits. So sometimes one thread writes 1 row, the other writes 1 row, but over here you see that thread 1 writes 2 rows. Over here thread 2 writes 2 rows. The sleep times are random, but in the end, fortunately we have 200 records, which is correct because we both threads wrote 1 record, both in the order and without the order. Now what makes this complicated, we can see if we set breakpoint in the worker. Let's go here. Okay, I'm in the, now since we're running multi-threaded, if you do that, it's not for the faint-hearted. So it is kind of complicated, but in Visual Studio we have a threads window, and as you can see now, we actually have 4 threads running. We have 2 worker threads, one called doWork2, one called doWork1. We have the main thread, but there's also the GC, the garbage collector, which is also on a thread. And right now we're in thread number doWork2, which is thread number 4. And as you can see, it has just opened file test in area number 1496. Now let's run it again. Now it stops here too. And now we see the thread state for thread number 3. And it also has the test work area with the same alias. And it also has 1496. So in some way, both threads have their own runtime state. Now, it's not just that they have their own list of work areas, but they could also have different settings for set deleted, set exact, etc. I know that in this case, they're running the same code, but, so these settings are the same. But they could very well be different. We have tried to make our runtime state in such a way that if one thread sets deleted on and the other sets deleted off, that they will not step on each other. So this is why each thread has its own set of work areas and has its own set of settings. Now, let's stop this. No, I don't want to stop it. Yeah. Now, if you have a look at the code, you see that this is well-behaved code. So the person who wrote this, Andreas, decided to close his server. So this method call to server close is now executed within the thread. What would happen if we would comment that out? Now things would become complicated. And I'll let you see what's happened by switching to a set of debug assemblies. So I'm going to remove now. It doesn't work. Why not? Something is locking my assemblies. But I'll just rename them. Been there, done that, as you can see. So now I've removed the release versions of the assemblies. I'm going to, hopefully this works. Going to add debug versions of the runtime assemblies to the global assembly cache so I can set a breakpoint. And we go back to our multithreaded. And then I want to open a file. Let me see, I think it was in DB server. Come on. No, wrong one. Okay. So what I changed now is that I didn't close the servers. That means that servers that were opened in one thread are now actually not closed in a thread. So what we see now is that at the end of the program, the .NET garbage collector detects that there's a server object and no one is actually has closed it. So it calls the destructor, the finalizer, you would call it, the C#. And in this server, we have registered that it was opened with an alias test, and it should be somewhere work area number, which was 4096, as we can remember. But the particular thread is gone, and there's no runtime state or nothing in the garbage collector thread. So if we wanted to close, and I'll show you the original code was this. If you wanted to close a work area using the work area number, there is no work area 4096 opened in the garbage collector thread. So this actually is a trick, or is risky. If you store something in the runtime state, you have to make sure that it's collected or cleaned up before the runtime state is gone, because the garbage collector runs on its own thread. Now we managed to do that by actually keeping track of the object of the RDD with the collection in which it was stored, the work areas collection, and which is also, and now in this work area, now I have the right collection of work areas, and it's going to find the work area here, and then we can close it. And now we're actually inside the work areas, and there is my test again, which is now in the scope of the list of open files from what was thread number 2, I think. Anyway, doing something multi-threaded is really cool, but can give you some headaches with regard to cleaning up. So what we try to do is find these problems, but if you have historic code like this code, which runs in a destructor, you should be aware of the fact that destructors are running in a separate thread. This is one of the reasons why we've chosen for file handles, so that you create with fopen, fread, fwrite, not to store in the runtime state. These are stored across all threads in the table, so you will not have a problem there, because the file handle is not thread specific, so it's not dependent on the runtime state. But other things like the deleted flag or the current work area number or these things, these are thread specific. Yeah, this is actually in short what I wanted to show today. Do you guys have any questions in this area? Do I need to show more? Do I need to explain things a bit more? Please. Nothing?
This is Matt. I'd like to ask a question.
Yeah.
Would there be a way to get, if I wanted to write like a little utility to run inside of my app that would could pop up like a win form or write some of those values to a console screen that you showed in the watch window, instead of sort of manually interacting with it within? Could I just dump everything out and write some utility?
You want to do a display status?
Sir?
You wanted to do what Foxpro does with display status?
Yeah, anything like that that gave me a way to sort of maybe just build my own interface to it outside of what Visual Studio has inside of Visual Studio. Something I could see at runtime from my app itself. Yeah, well, this is fairly high on my to-do list. What I want to do is add in one of our assemblies a state debug window, basically, where you can see all the settings, you can see the open work areas, you can see the private and public variables, so all that kind of stuff which is stored in the runtime. Chris has his own IDE, and he already has a window to show you work areas and settings, but I want to extend it a bit more and just put it in the runtime, so you can actually with a function call or a method call bring up that window. Now I'm not 100% sure whether this should be a modal window or a modeless window, and how to actually integrate it with your app, but my current thinking is just a WinForms window with a few list boxes on it or grids on it, where you can actually see this information.
If you add your own menu option to your app, you could just open it up and show that. Everything is available, so it's really just a question of designing a proper window and showing the information there. It's not much work, it's just nobody has done it yet. Chris has something in his X IDE that looks like this. I'll show you. Actually, there's a sample. Let me see, what was the file demo? I'll just open the demo customer and then now he has something that's, where is it, debug, view DB work areas. Something like this, where you see the actual customer DBF opened. These are its properties. These are the field names. And he has a button here that actually skips through the record, so it updates this grid and shows you the first. This is something that I was thinking of building in to the app. Indexes are missing here, but that's something on Chris's to-do list.
Yeah, that looks really awesome. And
for settings, so you could see all the settings in your app. This is actually a subset of the settings. I would just want to bring up the whole dictionary where you actually see the setting and its value. Now the next question is, of course, can you edit it there? And that's probably possible too. That's really not too much work. The UI
so
stuff.
Try. I don't remember at all, but give it a try.
Sorry?
I don't
change this here?
remember that works.
Oh yeah.
I'm not sure, but
yeah, it works.
Give it a try.
Yeah, this actually works great.
Okay.
Yeah. So
Type, yeah.
all of those tools that you just demonstrated in the XIDE editor, those look very, very familiar to some of the Fox Pro, IDE experiences that, one can get when you've got a lot of, that looks great, look very, very appealing. Yeah,
this is my idea. What's not here is the private and public. Now this particular app doesn't have them, but let's say if in a normal debugging environment, you can see locals and globals. But if your app is compiled and running, those are gone. Oh, the globals in theory, we could using reflection, we could find the globals, but locals, there's no name information available. However, privates and publics are stored in the runtime, in the table, and we already have enumeration code built in. So you can say, give me the first public, give me the next public, etc. And using that, we can create a window that shows you the dynamic memory variables with their names and values. It's just a question of priorities, basic math. And my personal priority is usually not UI stuff. I'm not particularly fond of doing UI stuff, but unfortunately, you're sometimes forced to do that. If anyone wants to help me out with UI stuff, I'll be happy to do in the plumbing there and to push the data into it. But if so, it's just not my favorite line of things to do.
No, I think that would be great for just sort of the scalability of development of this stuff. I like the idea if you did sort of some plumbing level, low level stuff to just basically show somebody how to hook into that stuff and make a rudimentary UI, and the first person who comes up and complains about a feature that's missing, they have to, take it from there and sort of implement it. And that way you and the rest of the X Sharp dev team can stay focused on some really lower level important parts of it. And
just to give you a rough idea, we saw already in the debugger that I did runtime state work areas. Now, you could directly access it here too, and then actually get its properties and get, because it's just code, so X Sharp. Actually, it has everything is in here. So we have, we can ask for an IDD, or we can get aliases for numbers. Everything is in there. So it's just a question of writing code. And if for whatever reason we have made something private that you need, or of course we can make it public, but there's fairly easy tricks in .NET to even access private properties by calling doing a fraction. So everything is available. We just to keep it simple, we're hiding some things sometimes, also because we may want to change the implementation in the background. But in theory, you can access everything if it's managed code, which is everything we do. So yeah, it's available and we could do it. If someone wants to design a window, and I'm thinking about settings, all the open cursors, and public-private variables. Those are the most important ones. But if someone says, oh, I would like to see a list of all the low-level file handles that were created with fcreate or fopen, it's just a table in the runtime. So we can give you the access to that, and you could enumerate that if you want. And you could abuse it if you want.
One thing that is a little more difficult, and it's not a function of X Sharp at all, it's really just Visual Studio. In FoxPro, we're sort of spoiled in that if we put a breakpoint in your code and it comes to a stopping point, you can go to the FoxPro command window, and you basically just have this REPL where you can just do stuff. You can launch forms, you can launch these little utility tools that and they do have access to all the in-scope variables, private, even locals are available at the command window of FoxPro, and you can sort of just on the fly invoke some of these tools. But with Visual Studio, the way it seems to work, you almost have to kind of predict ahead of time, or when you wanted to debug, you have to go to your code and add some more code in there to invoke, oh, now pop up at this point in my code, throw up the so-and-so form so I can look at it.
Yeah.
We need them, and then you have to comment that out when you go to actually build your app, or it'll still be in there. So it's kind of just unfortunate that the Visual Studio runtime thing makes you use the code. The running code is about your only hook point outside of the Visual Studio IDE itself, down there in the watch window and the locals and the call stack. But
well, yes and no. It's not. It's I wouldn't say it's easy, but we could build in a REPL window in Visual Studio too. C# has that. Our X Sharp script interpreter is like a REPL window, and we could hook that up with Visual Studio. And what it would do is you type in a line of code, it actually lexes it, so it scans it for tokens, it parses it, and then executes it. And within the context, well, that would have been the thing. You have to decide then in this window if you actually want to evaluate it within the context of the running app, or if you want to evaluate it, if you have no debugger running, if you want to evaluate it in the Visual Studio IDE. So that particular window has to be smart enough to switch between evaluating inside the app that's being debugged or evaluate, let's say, in the global Visual Studio. But in theory, that's possible. It's just a question of time and priorities. We'd love to do that.
Is there a way to access one thread from one thread work areas opened in another thread?
Good question.
If I provide synchronization, some exclusiveness, locks, etc., that's what I do. But is there a principal way?
Let's share a window again. No, I don't want to. I have to remove this. Come on. Yeah. What we've done in the runtime state, we've used a .NET class called threadLocal, and it actually keeps track of all the runtime state objects. And in the work areas class, we have done something similar. Let's see, where is it? No, wait. It's been a while since I did this. Oh, actually, the work areas object is stored as a property of the runtime state. Now, at this moment, we do not have a property on the runtime state to get the state of, and as such also the work areas of another thread. So that's not there. However, it would not be rocket science to do that. The only thing at the moment, I don't know exactly how the threadLocal class actually keeps track of all the different state objects, but that would be something to inspect. What we're doing in other area of the code is actually what we do allow is to create an RDD in one thread and then bring it over to another thread. That's what I'm doing at the moment in the Visual Fox Pro, where we run asynchronous SQL statements. So for asynchronous SQL statements, where are we? I have a background worker, it's called background worker, what else? Which actually creates an RDD. This is this ORDD object. And then when it's finished, we're actually moving this particular RDD and moving it over into another one. So we store this RDD object, in this case, in a slot of a SQL statement object. And then when the thread is finished and we're in the main thread again, I'm actually taking this RDD object and then migrating it over from the thread where it was created to the thread where it's actually now needed. So that's what we're doing here. In a similar way, we could probably find an RDD object because there is a table of all open RDD objects with the work areas they belong to. And I mean, the work areas collection is like a data session in Fox Pro. So it's a collection of open cursors, basically. So we have that mechanism and we're using it, and maybe we need to expose a bit, but there was no need for it until now, so we haven't exposed that, but it's possible, yeah, definitely.
Okay, thank you. And another question. If I have a DB server opened in thread A, and it's associated with area number 1, for example,
yeah,
and I pass it to thread B by reference, this object, DB server object, and someone calls some methods of it in thread B,
yeah,
and it tries to read something from that area number 1, but in thread B, area number 1 is something else. Maybe it's not open. So that would be an error.
It depends a bit on what you're doing. But this is actually beyond the scope of the runtime state. It's more like the RDD. But the RDD itself is a class. So there's if you read a field, it's just a get value on this class. And this class itself is actually keeping track of the file handle and the buffers, etc. So that's really not a problem. It may become a problem if you start updating the RDD, and especially if the RDD has an index, because if you update a row in a file which has an index, the index expression has to be evaluated. And the index expression gets evaluated in the work area number that's associated with the RDD object. Now, in the other thread, there's another work area number, so that could become a problem. But if you're reading, you should be fine.
Okay, thank you very much.
Anything else? We're already way beyond what was planned for today, 45 minutes, I see. No? Then I'd like to finish it for now. Thanks a lot for joining. I hope you pick up something useful from this. If not, it was nice to have you here. I see we had about 25 people, which is good. We're going to save this in our YouTube Academy for X Sharp. So if you want to refer someone else to this or to show some information, that's fine. You can find it on the web. We'll post the link in a message on the news group or forum, and well, you'll find it in our academy as well. If there are any other questions, no? Then I suggest we stop it for now. Thanks a lot for attending, and next week the plan is to spend some time on new features in the language and in the compiler.